multiply out the one on the left. Is that okay with you guys? Here's what we're going to get. I'm going to get sine A plus cos A multiplied by another sine A plus. You cool with that? Sine A by sine A. Sine A by cos A. Sine A cos A, yeah. And then cos A by sine A. Also a sine A cos A or cos A sine A. Doesn't matter which way it is. Once we add them both together. Okay. Cos A by cos A. Now, here's the kicker, right? Ready for this? Now, I'm going to look up sine 2A. It says part of this should be sine 2A. I'm going to look up sine 2A. Everybody see sine 2A here? What does it say beside it? I think that the 2 sine A cos A on the left relates directly into sine 2A on the right. Now, does everybody remember this rule from the last exercise? What's sine squared A plus cos squared A? Has to be 1, doesn't it? So this is all on page 13 and 14 of your tables. Sine squared A plus cos squared A is 1. And 2 sine A cos A is sine 2A. We're done. You cool? All right. Tell you what. You guys give A part 2 a go on your own and see what happens. My advice for A part 2 is I would change the cos 2A into something. So see your cos 2A? I would go up here and I would change it into this here. So my advice is to change your cos 2A into this blue part here. Right, go on, give it a go. I'm going to give you a small hint, okay? You ready for this? Does anybody remember what x squared take away y squared is again? X plus y and? Do you remember the difference of 2 squares? Remember, like x squared minus 36 would be x plus 6 and? Yeah, now the reason why I'm showing you that is, did anybody elaborate that to cos squared A take away sine squared A? They're the difference of 2 squares as well. So that would be actually cos A minus sine A and? Oh, yeah. And then what's a cos A? Yeah. So what we're changing cos 2A, we're changing cos 2A into cos squared A minus sine squared A. And then that in turn is the difference of 2 squares, which is cos A plus sine A multiplied by cos A. And then, lo and behold, what's on the bottom? Yeah, cos A plus sine A. And they're exactly the same. This is multiplication because there's nothing in between the brackets. So you're dividing all of this. Oh, why did I do that? You're dividing all of this into all of this. What's left over? Proven. Happy days? Okay, that's 8.3, question 8. Okay. Do the following equation. You can do sine, they want me to do sine 2A or they want me to do cos 2A. Okay. Now, whichever formula you pick. So C cos A is 3 over 5. I'm going to represent that on a right angle triangle. What side is it? What side? It's cos. So what function am I using? CAH. Ever see CAH? What's the A value? 3. What's the H value? Huh? 5. I'm going to do Pythagoras' theorem, and I'm going to figure out what is the opposite value. Is that okay? So 5 squared equals 3 squared plus x squared, and most are saying 4, and most are correct. Okay. And 16 equals x squared, and x equals 4. I'm hoping you can do Pythagoras' theorem before you sleep at this stage, right? So is everybody happy with x value of 4? Now, believe it or not, I have 2 choices for this formula. Okay, I'll take choice 1 first. Okay, here's choice 1. What does it want from me? It wants sine. That's a circle. Happy days. It wants sine 2A, doesn't it? Everybody agreed? Okay, so here's what we're going to do. I'm going to read the sine 2A formula. Where's the sine 2A formula? There it is there. What's it? 2 sine A and cos A. How do I find out what sine A is again? Opposite over Guys, you listening? Opposite over hypotenuse. 4 over 5. What's cos A? 3 over 5. And guess what? The answer to this is going to be 8 times. It's going to be 24 over 25. You cool with that? I could have also done the other option. The other option was to use the tan formula for sine. Ever see the tan formula? I could have used 2 tan A over 1 plus tan squared A. What would tan A have been again? What's tan A in this triangle? Huh? Would have been 4 over 3. I could have lobbed all that into the calculator instead, and it would still kick back out 24 over. Your choice. Is that all right? Any questions on that one? Okay, lads. 13 has a bunch of tans in it. Okay, so when I'm starting off this question, okay, all right, it's asking me to prove a formula that we already know. Does everybody see this formula here? It's asking me to prove that formula. Okay, so it's going to ask me to prove the blue formula using the other formula that should be exactly the same as it. Do you see the way these two formulas actually both represent sine 2a? That means that technically speaking, I should be able to turn this formula here into 2 sine A and cos A. Would everybody agree with that? They're meant to be equal to each other. So here's what we're going to do. Here's what I recommend we do. We turn all tan A's into sine A's over cos A's. Does everybody remember we did that in the last exercise? All tan A's turn into sine A's over cos A's. So you tell me what goes in the missing position. What goes here and here? Sine A over. And the other one? Sine A over cos A. Go with that? 2 sine A over cos A. And on the bottom? What happens when I square it out? What happens when you square out a fraction, lads? What happens when you square out a fraction? Huh? If I square x over y, it turns into x squared over y squared. So what do you think this turns into? Sine squared A over cos squared A. Go with that? Okay. Do they have a common denominator? Top one does, the bottom one. So if I say go out back the way it was in September with you, the yellow one has a common denominator of cos A. However, the blue one clearly doesn't. Does anybody want to make a change to the blue one that would help its cos? Yeah, just change it to cos squared A over. Excellent. We're happy with that. Cos squared A over cos squared A. Okay. And cos squared A over cos squared A. Happy days. And I confused the fractions then. I confused the denominators, can't I? What do I mean by fusing the denominators? Yeah. And you heard me talk about this earlier today, just making sure that's just one denominator and not two. That is a terrible line to use. Use this one here. Okay. Now, what did we say when we're dividing fractions by each other again? We did it earlier today. Bring the blue one up and turn it upside down. Let's do that. 2 sine A over cos A multiplied by... Oh, while we're here, what is cos squared A plus sine squared A? What is cos squared A plus sine squared A? What is it? On page 13 of your notes, on your tables. Cos squared A plus sine squared A is 1. So before I even do that, I'm going to change that to 1. Now turn it upside down. Now, cos A, what does it do? And what's left over? Cos A. And that's what we're looking for? Yeah. Happy days. We kill? Very difficult though, wasn't it? Okay. All right. A over Pick an angle, pick the side opposite it, pick another angle, and pick the side opposite, and write out a sine rule for it. Off you go. That's not a right angle triangle. Beta. 2 beta. 5 over sine 2b. 2b is what looks at the 5. And 3 over sine b. Cool. Which one does it want on its own? It wants sine 2b on its own. Are you cool with that? That's the one it wants on its own. So how do we fix that? Sine b is multiply on the right, which will make it what on the left? Oh, sorry, it's division on the right, which will make it multiply on the left. Sine 2b is division on the left, which makes it what? Multiplication on the right. The 3 is multiplication on the right, which will make it what on the left? And would everybody be happy with that? So what's A and B? A is 5, B is 3. You all good? Okay. Hence express tan B in the form root C over D. Oof. Yeah. Have we used our double formula yet? Our double angle formula yet? We haven't, have we? No. You have a choice. Here's your 2 choices. The first choice is sine 2b. You can use sine 2b equals 2 sine b cos b. That's not too bad, is it? Looks basic enough. So why don't we replace sine 2b with this here? Does that make sense? We are in the double angle formula chapter, right? So look what happens here. Lads, anything cancel on both sides? Is there anything that's on both sides that is the same? What? They're all B's, mate. Oh. Now, see the sine B on the left. So this sine B is multiplication on the left. And if I was to bring it to the right, it would just divide the other sine B, wouldn't it? So in essence, they just cancel each other off. So the 2 sine B's cancel each other off. You cool with that? What's the goal of the question again? Who wants to figure out what? Okay, no bother. I'll figure out what cos B is first, though. Everybody agree, bring the 2 down. And what's cos B? 5 over 2 times 3. Right? SOHCAHTOA. What's cos represent again? Adjacent over. Hypotenuse is adjacent. 5. Do Pythagoras' theorem. 6 squared equals 5 squared plus 36 equals x squared. X squared equals 11. X will equal square root of 11. Anybody care to tell me what tan is then? What's tan B? Tan B is opposite divided by adjacent. Is root 11 over. And that meets the description of the question.